So the previous video explored a little bit of the history of the periodic table. So the very first periodic table by Dmitri Mendeleev. We looked at some fun periodic tables made with candy and Disney characters. Now let's jump into the current periodic table, the one that you are going to be most familiar with and be using in this course for the remainder of the semester. So we're going to talk about each little square, each little house for an element and the information that is in that square. We're going to be talking about that later, but let's first look at the periodic table in terms of just some basic components that it holds, which is namely symbols and names for elements. So this is just showing some examples of symbols and names for elements. Most elements have a 1 to 2 letter abbreviation. Some are a little more obvious than others, like S for sulfur, Cl for chlorine. Some symbols aren't very obvious at all. You wouldn't think K would be potassium, but some atomic symbols that are on the periodic table are taken from an earlier name, either Greek or German. I think my favorite is the symbol for mercury, Hg. It's based on the Latin for water silver, which I think is a great way to name mercury, because that's certainly what it looks like, although you certainly wouldn't want to play with water silver. So the periodic table for each element lists its name and its abbreviation. And the periodic table that you will be using in this course will have that information on it. You don't need to know these earlier Greek or German names. But you do need to know that the periodic table has names and symbols for elements, and that there are two broad classifications of elements. Metals. Metals are located on the left-hand side of the periodic table and in the middle. There is one exception of hydrogen. Hydrogen, for reasons we'll talk about later why it's placed over here, but hydrogen, along with elements on the right-hand side of the periodic table, can be defined as a nonmetal. So by far, there are more metals in the periodic table than nonmetals. But if you think about biologic life, or carbon-based forms, carbon, oxygen, nitrogen, and sulfur, the majority of biological life deals with these nonmetals. Staggered on the periodic table in between the metals and the nonmetals are elements that have properties of both. That's by the elements by this stair step in purple. Those are called metalloids or semimetals. Those elements are very important in your cell phone and in our computers as they're used as semiconductors. So those are just some general properties of metalloids, but you should know those two broad classifications, where they are located on the periodic table, and know the elements in between them are metalloids. And this slide is just showing you some properties, some physical properties of metals that I'm sure you probably knew already. When you think of something that's a metal, you think of something that's shiny, conducts electricity and heat. So you can read these on your own. I think the most important point of this slide is the point by this star in the two cartoons, which is that metals, those species on the periodic table that are on the left-hand side and in the middle, when they form molecules or compounds, when they get together with another element, they like to form compounds that are called ionic. And ionic comes from the fact that the bond that is formed between the metal and the other species, which is actually a nonmetal, but that bond is called an ionic bond. And metals, when they form an ionic bond, that ionic bond is formed by the loss of electrons. So metals lose electrons in ionic bonds. So for example, if I have a sodium atom and a chlorine atom, and these dots are electrons. Now, why there's 1 here for sodium and 2, 4, 5 here for chlorine, we'll talk about later. This cartoon is just to illustrate that when forming an ionic bond, the metal, in this case the sodium, completely donates that electron to the other atom, to the nonmetal. And when it does that, when sodium donates that electron, remember electrons are negatively charged, so when the metal does that, the metal becomes positively charged, as is shown here. And metals that are positively charged in ionic bonds are called cations. So that's a term that you should know as well. Cations are positively charged species that are metals. So metals, they form ionic bonds, and in ionic bonds, electrons are taken, not shared. Specifically, the electron is taken from the metal and given to the nonmetal. Nonmetals, here's some characteristics here of nonmetals, but again, I think the most important point about the nonmetals is that when they form compounds with other nonmetals, not with metals, but when they form compounds with other nonmetals, those compounds are called molecular compounds. And molecular compounds make use of a kind of bonding called covalent bonding. So in covalent bonds, electrons are not taken, they are shared. So electrons are shared between those nonmetals to form the molecule or to form the covalent bond. So nonmetals, covalent bond, shared electrons. So those are characteristics, properties of metals and nonmetals that you need to know. In the next video, we'll dive in more into the periodic table to learn about how those metals and nonmetals are categorized in terms of periods and groups.